Input-output boxes. Your learning target today is I can find the pattern in an input-output table to complete the table. I'll know I'm successful today when I can find the rule of the table by thinking of all four operations and finding which makes sense with the pattern, and then filling in the missing numbers. Today we are going to be learning about in and out boxes. So with in and out boxes, or another word is input and output boxes, usually there is a rule that is either told to us that we need to follow for these boxes, or sometimes you have to figure out the rule on your own. So for this first example, I'm going to tell you the rule, and with the rule, we're going to follow the rule, and that rule is going to all go in our output box. You can see in the in box that we already have our numbers all filled out for that. And for the out box, well, we need to fill that in. So I'll tell you what the rule is. The rule that we need to do is we're going to add 3 for each of these numbers. So what that means with 4, we would do 4 plus 3, right? That is the rule. And what is 4 plus 3? Well, that's 7. So that would go in our out box. What would we do next? We'd go down to the 5, and again, we're going to go to our rule and say, okay, add 3. 5 plus 3, 8. Okay, then we have 6. We're going to think about our rule again. That's add 3, so 6 plus 3 is 9. And then we have 7. 7 plus 3, which is 10. So you can see with an input-output box, when we're given the rule, we look at the input and we have to fill that in with our rule to come out with our output or our out, right? I like to sometimes think of an in as like a before we apply the rule, and then an out as after. So this is like the after we apply the rule, right? Adding 3. Oh, after I add 3 to 4, I get 7, right? Before and after. That's kind of like how I like to think of it. Now I'm going to show you some more examples of how we can do an output box, when I do not give you the rule, but you'll have to figure it out on your own. So let's see. So this time I have an input-output table that is partially filled in, but not all the way. I have some inputs, but not all of them, and I have some outputs, but I don't have all of them, right? And my rule, I don't know. I have to figure it out on my own based on how this box is filled out. So let's look at the first one. We started with in the in box with 7, and when it came out, it's a 4. Okay, so think about what happened right there. And then if I go all the way down to that 16 in our input box, I can see that in the output it's 13. So based on that information, what do you think that pattern is, or that rule that happened? What happened to both of those numbers? 7 to 4 and then 16 to 13. It looks like the rule is subtract 3. Okay? Or minus 3. Because 7 minus 3 is 4. That makes sense. 16 minus 3 is 13. That makes sense. So let's go down in our input box and find the 10 right here. And let's follow that rule. 10 minus 3, 7. That's how I can fill out the empty box. Now let's go to our empty input box. I have an empty box, but output is 10. So that's after I applied the rule, right? That was after I did minus 3. So blank minus 3 equals 10. What number would go in that blank? 13, right? 13 minus 3 is 10. So that is how I would fill out an input-output box when I do not know the rule. I have to figure out the rule, and I have to find out what is happening with the numbers, like what's the pattern, to be able to fill out all of my boxes accurately. Sometimes with in and output boxes, I can also find more patterns, more than adding and subtracting. So let's look at this pattern and this rule and see what this rule might be. So looking at the input, remember that's kind of like my before. Before I apply the rule, I have a 2. And then when it comes out, after I apply the rule, it's a 4. Okay, so far it kind of looks like, okay, maybe that's a +2 rule. But let's see if that's true. Let's go down to the next one where I have both the input and output that I know. 9 and 18. Okay. Before the rule it was 9, after the rule would be 18. Ooh, would that make sense if my rule was +2? 2 + 2 was 4, right? So is that the rule? 9 + 2, is that 18? No. So +2 is not my rule. Okay. Oh, I know. The rule is not +2, it's ×2, right? It's like a doubling rule because 2 × 2 is also 4. And then 9 × 2, that's keeping up with the same rule, is 18. So our rule is ×2. Or you could also say your rule is to double. So doubling 2, right? 2 + 2 is 4. That's if I doubled it. And 9 + 9 is doubling to 18. So you could say this is a doubling rule, or it's just a ×2 rule. They're the same thing. ×2 is just like doubling because you're adding that same exact number twice. So that's our rule. Oh, awesome. Okay, so I need to fill in the rest of these boxes. Let's look at our 12 down here at the bottom of our inbox. And when I think of the doubling rule, or ×2, if I did the doubling, I would do 12 + 12. If I did ×2, it would be 12 × 2. They're the same thing, right? What would that be? What is 12 × 2? Or what's 12 + 12? 24. Nice job. So let's go to our last blank. I know the output is 14. Oh, so what would be before I double it? Ask yourself, what plus what equals 14? And they're the same number. Or, what times 2 is 14? You might know that one. I know my ×2 facts, and I know 7 × 2, or just like the doubling rule of 7 + 7, is 14. 7 + 7, or 7 × 2 would work. So 7 is the input. So we're going to try one more together. And remember, I want you to pay attention to figuring out what pattern is happening. And tell me the rule, and then we can fill out the rest of the boxes. So for our last problem today, I want you to try this one out on your own. So remember, look at the input and the output. Look at that first, and then look at the output, where that's like a before in the in and then an after in the out. So before the rule, we have 6, 8, a number that we don't know yet, and then 11. For the output, we have 8 turns to 40. Okay, and then we know that 11 turns to 55. So what would be the rule? I want you to pause the video and figure out the rule based on that pattern. What's happening? Remember, it could be an adding rule, it could be a subtracting rule, it could be a multiplication rule, or it could even be a division rule. Okay, any of those 4 operations. But remember, it has to be the exact same rule for each one. So if a rule works for one of the things, but not all of them, then that must not be the rule. So make sure it's the exact same rule for each input and output. And once you figure out that rule, I want you to fill in the rest of that box. So please pause the video and try that right now. Okay, so if you resumed the video, that means you figured out this rule and you figured out all of the blanks in the box by yourself. And now you're ready to check your answer. So when I looked at 8 turning into 40, and when I looked at 11 turning to 55, I automatically knew that that is a times 5 rule, okay? Because I know 8 times 5 is 40, and I know 11 times 5 is 55. So all of these numbers are being multiplied by 5. So for 6 times 5, what is 6 times 5? You should have filled in 30. And then we had 50 right here in the output. So that means in the input, that is going to be before we multiply by 5. But in order to do that, what would be like going backwards for when I multiply? That operation we would do would be divide, just to figure out what's in this box, okay? Or, oh, something times 5 is 50, right? Well, what's 50 divided by 5? 10. So that's right, because 10 times 5 is 50. See how I could use division just for this rule, because it's kind of like I'm going backwards? But our rule, and it stays consistent, was times 5. Or you could have said multiply by 5. Nice job today. And we are going to keep practicing this, because not only does this help me with in and output boxes, but it helps me with learning patterns and learning how to figure out something with all 4 operations. So remember, your learning target today is I can find the pattern in an input-output table to complete the table. And you'll know you're successful when you can find the rule of the table by thinking of all 4 operations and finding which makes sense with the pattern, and then filling in the missing numbers.